So we get to start chapter 6, which I know you're excited about. And chapter 6 has what's called differential equations. So we're going to talk about what a differential equation is. I don't know. It's a good question. A lot. Okay, so a differential equation is an equation that has a derivative in it. An equation that has a derivative in it. So I'll give you a pretty simple example. dy dx equals 2x plus 7. That's called a differential equation because it's got an equal sign in it, so it's an equation. And it's got a derivative in it, so it's a differential equation. And don't mean to big up bad memories, BC, but last week on the cow you had a differential equation. X times y prime plus y equals cosine of x. That had a y prime in it, so it had a derivative in it, so that was a differential equation. Okay, so a differential equation is any equation that has a derivative in it. All right, so then when you solve a differential equation, that means find the original formula for y. So a differential equation is an equation that has a derivative in it. And then when you solve that, that means find the formula for y. So if you wanted to find the formula, if you wanted to solve this, what would the solution be? X squared plus 7x, right? Plus c. So there's a lot of different solutions. If it says solve, there's a lot of possible answers. One answer is y equals x squared plus 7x plus 12. That's a specific solution. But there's something called a general solution. And the general solution means it's a formula that represents all the solutions. So if I gave you this differential equation and I said solve and give the general solution would be x squared plus 7x plus c. And the c just represents all the different solutions it possibly could be. So that's called the general solution. Okay, so if you had x squared plus 7x plus c, how could you find a specific solution? What information would you need in order to figure out what c was? You'd need a point that was on the solution, right? So in order to change a general solution into a specific solution, you need a point that's on the equation. So that point is called the initial value. So the initial value is one point that is on a curve, and then this allows us to find a specific solution You know what? I want to, instead of saying specific, I want to say a particular solution instead of a general solution. So wrapped up in there is also the fact that a particular solution is another name for a specific solution. Okay, I think that's all the vocabulary I need. Yeah, that's good for now. Okay, so now let's try a problem. So for example 1, we've got find the general solution to the differential equation. And the differential equation is dy dx equals the sine of x minus e to the x plus 8x cubed. And this problem is so much fun, I'm going to give you 2 different answers. So, for method 1, so just to review, why is this a differential equation? Because it has a dy dx in it, it has a derivative in it, right? And when I ask for the general solution, what does that tell us our answer is going to have? Plus c. We don't need a specific solution. We don't need a particular solution. We're allowed to have plus c in our answer. That's what general solution is. Okay, so what is the, oh, and sorry, when I find the solution, what am I looking for? What y equals, right? Solving means figure out what y equals. All right, so I need an equation for y. So what does y equal? Yeah, negative sine or negative cosine of x, right? Because the derivative of cosine is negative sine. So the antiderivative of sine is negative cosine minus e to the x. Because the antiderivative of e to the x is just e to the x. Plus 2x to the 4th. I could have written down 8x to the 4th divided by 4, right? But I just skipped that step. Plus c. So there's the general solution. It's called a solution because it's what y equals, and it's called a general solution because it's got a plus c. So there's a lot of possible answers, and this plus c represents all those possibilities. Okay, what's another way to do this problem? Priyanka's up here making a curved symbol. You know what she means? You could just slap an integral sign on this thing, right? And then it finds the antiderivative. That's the sly way to find the antiderivative. Okay, so if I do it that way, y equals the integral from a to x under sine of t minus e to the t plus 8t cubed dt plus c. So why does this work? Because if I take a derivative of an integral, they, in some sense, cross each other out, right? And so this is why this is the antiderivative. Okay, so we have two different answers, which is kind of awkward. So we need a name for these two different answers. So this answer is called the explicit solution. So I guess this one's more dangerous. Explicit lyrics. Stay away from it. I know you've never heard anything like that. So this is called the explicit solution, and then this is the solution using the fundamental theorem. So sometimes they won't care which one of these answers you give, so they'll just say solve. But sometimes they will care. And so if they say solve explicitly, that means you're not allowed to just slap the integral on it. You have to give this. Or if they say solve using the fundamental theorem, they're saying do this. Okay, let's see what else I got. So this would be example 2. I'm going to solve the initial value problem. Explicitly. And the initial value problem is dv dt equals 4 secant t tangent t plus e to the t plus 6t, and then 0, 5. No, it's dv dt. So I switched the variable on you. That's all good.
Is that plus e dt or times t times e?
That's plus
Okay.
e to the t plus 6t. Sorry about that.
That's okay.
I try to put curly q's on my t's and straights on my pluses, but it still is not clear. So thanks for asking. Okay, so it says solve, so what does that mean? Find the original equation. A lot of times it's y, but in this case it's going to be v equals. Okay, so find the original equation, v equals. It says solve explicitly, so what does that mean? Can't put an integral sign. I have to actually find the antiderivative. And why is it called an initial value problem? Because they gave me a point. And so that's the initial value. And what's that going to do for us? We're going to be able to figure out what the c is. So we won't have a general solution, we'll have a particular solution. All right, so just taking the antiderivative, v equals, the antiderivative of secant times tangent is secant. The derivative of secant is secant times tangent. So the antiderivative of secant times tangent is just secant. Everybody okay with that? Okay, then of course the antiderivative of e to the t is e to the t. And then this would be 3t squared plus c. So that's our general solution. But now we can use the 0.05, we can use our initial value to find the particular solution. So we know when we plug 0 in for t, according to that information, so when we plug 0 in for t, we know that we're supposed to get 5 out. Everybody good? Okay, so then e to the 0 is 1. That's 0. I'm leaving this for last because that's the hardest, right? We've got to figure out the secant of 0. So that's on the unit circle. Here's the 0 radian angle. There's the point 1, 0. That's associated with it. Secant is the reciprocal of cosine. The cosine of 0 is 1. Reciprocal of 1 is 1. So secant of 0 is 1. So that's 4 times 1, which is 4. And so C comes out to 0. So final answer is V of t equals 4 secant of t plus e to the t plus 3t squared. Then you could write plus 0 if you wanted to, but you don't need to. You look concerned. You're good? All right. Everybody else good? All right. Okay, now we're going to solve the initial value problem using the fundamental theorem. And it's dy dx equals the sine of x squared. And then we're going to have the point 1, 5. So this is the derivative. So if we're going to solve, we need to find the original equation. So we need to take the antiderivative. But one way to take the antiderivative is to just do this. So this is using the fundamental theorem. Because if you put an integral symbol around it, it finds the antiderivative, right? Okay, now I need to pick what A is, and I need to pick what C is. So I'm allowed to pick anything for A that I want, so I'm going to pick 1. The reason I'm picking 1 there is because now, if I stick a 1 in for x, this integral is going to be easy to calculate. What's it going to be? 0, right? So I slyly put a 1 there so that when I put a 1 there, this will come out to 0. Okay, so now when I plug a 1 in, I'm supposed to get a 5 out. So when I plug a 1 in, I'm supposed to get a 5 out. So that means that C is 5. So then my final answer is y equals the integral from 1 to x underneath sine of t squared dt plus 5. Everybody doing okay? All right, we're switching gears now. We've got the integral from a to b of f of x dx. What does this mean? What does it tell you to do? Find the area underneath f of x from a to b, right? Okay, so this means find the area. And when you find the area, you're going to get a number for your answer. Like maybe the area is 7, or maybe the area is 28. So since you get a solid number as your answer to this question, you get a definite answer, a solid number answer. So this is called a definite integral. So when you have the integral symbol with letter numbers here and there, it means find the area, and that's called a definite integral. And the reason it's called a definite integral is when you find the area, you get an answer, a number answer. One specific answer, a definite answer. All right, so now this is new. We're going to have an integral symbol without anything written on the top and bottom. This is the first time we've seen this. And what this means is take the antiderivative. So up until now, we haven't had a symbol that says take the antiderivative. We have had a symbol that says take the derivative. Right? That symbol means take the derivative. So now this symbol, the squiggly combined with the dx, those together mean take the antiderivative. Okay, now when you take the antiderivative, you have to put plus c on it. So you don't get a specific answer. You get a bunch of answers. So this is an indefinite integral because you don't get a specific answer. So this is brand new, but it's not hard. Indefinite integral, you're not going to have numbers on the integral symbol, and that just means take the antiderivative, which we already know how to do. Now we just have a symbol for it. Next, we are just going to practice a few indefinite integrals. So the first one is so you got a squiggly s thing in front and a dx in the back. What does that mean? Take the antiderivative. So all we have to do is take the antiderivative of x squared. What's the antiderivative of x squared? X cubed over 3, or aka 1/3 x cubed plus c. So we didn't get a specific answer. So that's why this is called an indefinite integral. We got a bunch of answers. Okay, how about this? Yeah, that's easy. Antiderivative of 5 is just 5x. And then plus c. Good. Go ahead, Tasha. 5t plus c, right? So the reason I did these two problems was to let you know that this is important. The dx tells you what the variable is, right? Without that, we wouldn't know whether this was 5x or 5t or 5 whatever. So back to a fine one, right? It doesn't really require much thought. 5x squared over 2 plus c, right? So apparently x is not a variable. T is the variable. So apparently x could be 3. If x was 3, then that would be 15, and the answer would be 15t. If x was 2, that would be 5 times 2, t. So it's 5xt. Because apparently 5x is a number. That's the most philosophical thing we've done today. Is everybody okay with that? Okay. We're going to look at another differential equation. This one is dy dx equals 1 over x. So just kind of generally without thinking too deeply about it. And then we're going to think deeply about it in a minute. But for now, not thinking too deeply, what is the answer? What is the antiderivative? Natural log of x, right? The derivative of ln of x is 1 over x. So the antiderivative of 1 over x is the natural log of x. Now that's not the complete story, and that's what we're going to talk about in this example. But that's most of the story. Okay, so for part A, we're going to show that y equals ln of x plus c is a solution on the interval 0 to infinity. So when you take an antiderivative, how can you check to see if you have the right answer? Take the derivative, right? So what I'm going to do is, in order to show that this is an answer, I'm going to take the derivative of it, and then hopefully I get that. So the derivative of y is dy dx. The derivative of natural log of x is 1 over x. And the derivative of c is 0, right? So this is kind of what I just said out loud, but that's right. This is a solution to this. Okay, now, but why does it have to be from 0 to infinity? No, that's not why. Sure, but why is that the range in which it's true? The issue is you're not allowed to take the natural log of a negative number. You're also not allowed to take the natural log of 0. So right here, x had to be positive. So you can tell that here, but here you can't tell that x has to be positive. So we better specify that. Since the original formula had to have a positive x, that means the answer has to have a positive x. That's all this is saying. Okay, so now for part B, I'm going to show that there's another answer to this. We're going to show that y equals the natural log of the opposite of x is a solution as well. Okay, so just like up here, I can take the derivative of this to check, right? So I'm going to take the derivative of this. The derivative of y, of course, is dy dx. The derivative of the natural log of something is 1 over the something. But then what else do I have to do? Multiply by something because of chain rule, right? This is a chain rule problem because there's a mess sitting inside of the natural log. So the derivative is 1 over the mess. But then I have to multiply by the derivative of the inside, and the derivative of negative x is negative 1. Good math. And then the negative 1's cross out, right? So the final answer is dy dx equals 1 over x. So that's another answer to this. Because the derivative of this is that, so the antiderivative of that is this. Okay, but why does this have to be on this interval? These are the negative numbers, right? Why does this problem have to have a negative number plugged into it? Because if you plug a negative number into it, then that opposite will make it positive, and then you'll be taking the natural log of a positive number, right? You're only allowed to take the natural log of positive numbers. So if you put a positive number in there, you're in trouble because you're trying to take the natural log of a negative then. So that's why you can only put a negative into there, because then you'll be taking the natural log of a positive. That was a lot. Does everybody understand? Are you positive? Sure. Okay. Okay, so let me summarize what I said here. So what I'm saying is that y equals the natural log of x plus c so what I'm okay, sorry. So if y equals the natural log of x plus c, that solution will work if x is positive, right? You with me? I don't know. I'm summarizing what I'm talking about, right? Because over there, if x was 0 to infinity, this was the answer, right? But if x is negative, that's the answer. So then this is a summary of the complete answer. The complete answer to the antiderivative of 1 over x is a piecewise function. That's a pain. So if someone says, what's the antiderivative? If dy dx equals 1 over x, then here's what y equals. Now, I would like to not use a piecewise function if I could avoid it. So I'm going to rewrite this piecewise function in a different way. So I could put an absolute value sign there if I wanted to, right? Because that's a positive number, and absolute value doesn't do anything to a positive number. Okay, then what is this doing to a negative number? It's making it positive, right? Isn't this making that negative number positive? What else makes a negative number positive? Absolute value. This is taking a negative number, So I could put an absolute value there, and I could put an absolute value there, and I have the same thing. So I could write this as y equals the natural log of the absolute value of x plus c. Yes. Doesn't exist. Good question. Well, there's two reasons it doesn't exist, Carter. You can't take the natural log of 0, and also you can't take 1 over 0. So there is no answer.
You don't need to label that on the answer?
I did. I didn't say anything about it.
You don't have to label it on the
So you're making great points, Carter. So to your first point, up here, since I said nothing about 0, that means I'm saying it doesn't exist. And here, since I've got a natural log symbol in front of this, we all know, quote unquote, that you can't take the natural log of 0, so we all know that 0 is not allowed there. Just like if you saw 1 over x, you would know that 0 wasn't allowed without specifying. But it certainly wouldn't be wrong to come out here and say x can't be 0. It would just be redundant. Okay, so the main point here is that this is a fancy way to write the answer to dy dx equals 1 over x. But this is a fancier way. Does everybody see that these are the same exact thing? And this one's a lot nicer than this one, right? Okay, so when you walked in the door today, if I had asked you what's the antiderivative, when you walked in the door, if I had asked you what's the antiderivative of 1 over x, you would have said the natural log of x, right? But the complete answer is that it's the natural log of the absolute value of x. And yes, plus c, that's right. But I wanted to focus on the fact that, so from here on out, don't forget, when you take the antiderivative of 1 over x, don't forget to put absolute value symbols around the x, because that's the complete answer. If you put this, you're only half right, because you got the other half of it. Is everybody okay with all that? All right, thanks for paying attention. Most of